Okay, here we are, Jeters. By the way, I think that's going to be my nickname for all of us on GTT, because GTTers feels it's a little bit of a optimization problem. There's just that takes way too long. Goju is so much faster. So hey, buddy, you want to come over here? Come on. Okay, I need to see the screen though, buddy. He stood up as soon as the daddy voice. The adult voice. Come on, buddy. Over here. Right. Come on. Merle. Here. Merle. And we just went on like a 3-mile walk too. Come on, buddy. What is happening? I think he wants to be where the mic is. He's eyeing it like, what are you? What is? Okay, come on. All right. Well, there we go. Yep. He's he's okay. So yeah, we'll figure out. Yes, I know. Yep. Okay. Yeah, we're gonna have a fun one today. So the Jeters thing. So GTTers feels way too. That's gonna take way too long. So Jeters, I think, is what I'm gonna refer to of us. We're the Jeters, and so welcome, Jeters. It's Friday night. It's about 12:30, midnight 30. And we're ready to do some stuff. So come on, buddy, what are you doing? Okay, he really wants to give me the kisses. No, listen, I gotta do this thing. Okay, what are we gonna talk about today? We're gonna talk about, well, yeah, we're not taking ourselves too seriously. We're gonna play around, and that was actually on he's helping with that. Cool. This is actually pretty important. I think I used to be super serious, and I know a lot of hyper intelligent people that are very serious, and I get it. Listen, I have my serious game face on all the time, but sometimes it's good to just kind of take it down a notch and, laugh at yourself. That's probably one of the most important things. And yeah, don't go too crazy. We should have like a little bit of fun. And I think it also makes it easier to grow when you know that you can make mistakes, and there are times to be super serious, and we'll be serious in those, but we don't need to be serious about everything. Be serious about the things that are worth being serious about. So today we're going to have a little fun. We're going to talk about technology that annoys me. We've got a few different technologies that annoy me. How did stochastic language models get on this list? And I don't know that OpenSSL annoys me. I just I wish that the code was maybe a little bit better. But we learned some stuff today about what's going on here. I want to talk a little bit about this. The big one that actually inspired this is this this first one. Why doesn't YouTube have a back button? We'll talk about this. So anyway, we're going to meander. And I also want to have a shout out to untranslatable metaphor 1449. This dog is like, if I had a camera, he's now laying on my lap desk. And so I have lost access to the mouse and maybe the keyboard. So yeah, we'll see I'm talking about you, buddy. No. Okay, cool. So let me first call out to untranslatable metaphor. we clearly have a superhero coder in the audience. If you aren't convinced by this comment, I'm going to quickly read this. That untranslatable metaphor left a day ago at 1 hour, 17 minutes, 28 seconds. Would it be possible to just deduce k-width from the type with a simple calculation, something like const expression size t bits equals size of t times 8, and then from there, once you have the bits, const expression size t width is equal to the bits divided by 7 plus the bits mod 7, if that is true, meaning that it didn't divide perfectly, then you return a 1 to give you this extra value, or return 0. And I haven't plugged this code in yet, but I have done similar things to what untranslatable metaphor is suggesting, and I believe he, she, they are right. I think that's right, and I love it, actually. This makes the other solution that I was recommending to rewrite this code, wherever it was that I was rewriting this code, somewhere in here. No. Oh, yeah, maybe I can follow the 117. 17, 222. No, here we go. Oh, I was doing it like, oh, yeah, it's a pseudocode. Oh, right, okay, over here. So, and by the way, I want to say, impressive, untranslatable metaphor, that I wasn't even writing compiled code, and I think I was saying, like, this is probably just going to be pseudocode-ish, and you were able to decipher my chicken scratches here, which I probably didn't get exactly right, understand actually what I was shooting for, and then revise it so we could get k-width actually figured out. I love this. This is awesome. And so we essentially get, we don't need the int const k-width with this change. It's super elegant. And what's great too is, for those of you that aren't experts in like template, C++ templates, or understanding the various sort of lower level details of some of the things going on in C++, is this size of t will essentially take the template parameter, which can vary, which is the whole point of me abstracting out this type. So you can have different, it can support different integers, like 32-bit, 64, 128, 256, which clearly our friend here was able to put together. And then you support all those various types, and you don't need this extra parameter, and you also don't need someone to calculate it. It's just better. So it reduces the complexity of this code by eliding away a parameter, and it also eliminates the chance you could get this wrong, because this was the value essentially for 64 bits, I think. I think that's what they, yeah. But as I was trying to point out, what about 128, 256, 512, 1024, all that fun stuff, which could, 384, it could exist. And I love it. So we are probably not going to fiddle with this right now. But I think that untranslatable metaphor is correct, and I absolutely love this solution. for the reasons I just described. Minimally, there's two reasons why I think this is super elegant. The first is it allows us to support these different sized types, int types. And then two, it elides away this parameter. I guess maybe this is the same thing. So it essentially reduces the fat finger-ish aspect of this. And overall, it simplifies the system. So this is just one of those cases where, in my mind, it's just better. It's just, this is the right kind of way to code. And I'm all for cases where, excuse me, I'm all for cases where we can leverage the system to essentially perform code calculations for us, which is why I kind of like templates, is they allow us, in some sense, well, there's many reasons why I like templates, but I really like generic programming because I think that it allows you to think at higher levels, like you're able to solve a whole bunch of problems at once, sort of ish. And then you can still specialize for the cases where maybe you need to have different behavior for this specific case. But I like that. And I also like, if I'm being honest, and I want to say, I don't know that this is necessarily a good thing. And so you want to be careful, especially if you follow my advice of don't flex when you're writing production quality code. Some people might say writing template code is flexing. And I have been yelled at in the past when I was just an individual coder and my engineering directors and stuff were not always thrilled that I was writing code that like two people on the dev team could understand. But I might have been saving all of us a whole bunch of time in dev by allowing us to generalize. But the bigger thing is when you write templates, at least for me, you get to think at higher orders of abstraction and solve problems in some sense like a more pure way. And I really like that. I think it's sort of like I'm verging on becoming like a functional programmer. You know, maybe the next step is to start eliding away side effects and things. So anyway, if you're a Jeter, we're probably going to be hacking on template stuff from time to time. In fact, one of the first things that I open sourced was this template tree class I created for Nautica, because I found it somewhat strange that the standard template library didn't have a tree container. Like, I know that trees are used to implement like sets and maps and things, I think. Anyway, or they were at some point. But why wasn't a tree container like exposed? Because sometimes I just want a tree. And so then I built one. And it was actually a little tricky because the iterators for the tree are trees themselves, which is kind of cool, but I mean, it does maybe increase the mental complexity. I don't know. I did it for Nautica, and then I open sourced it. It's out there in the wild, and I guess some people are using it. I used to maintain a list, but yeah, I think it's called tree. There's like tree.h, tree.h, and multi-tree.h. I think I wrote like a game dev article on it. This is a long time ago. But there you go. There's my contribution to open source. Yeah. And I don't know that it's perfect. Again, it's been a long time since I've looked at that code, but it is used, I think, all throughout Nautica, and it allowed me to do some pretty wacky, awesome things. So anyway, I like templates. Templates are fun, but generally try not to like super flex when you're writing production quality code, especially stuff that is going to be with other people. And I realize I'm contradicting myself a little bit here, so I don't know. This is a good example of I'm not taking myself too seriously with this episode. That I'm conflicted. Sometimes I want to just like get into really crazy, awesome things like this, and I'll be damned if people shut me down because it's too hard. I don't know. Like, I do think, actually, look, let's go down this rabbit hole a little bit. I do think that there is a danger where if you're having to code to the lowest common denominator, like this is one of the things that got yelled at about, is people were saying, only 2 people understand how to do like template metaprogramming, and so you're crippling the rest of the team. And my argument was, hey, the entire standard template library is written in templates, and for a reason. And so that's not crippling people. And then I think the argument that they had is, well, STL doesn't have bugs in it. And admittedly, I was doing some advanced policy thing it wasn't that complicated. I mean, I don't think it was that. If you were to ask like Andre Alexandrescu in modern C++ design and ask him if it's complicated, or any like the C++ standard committee folks, Andrew Koenig or Bjarne, I don't think that they would be like it's complicated. But I understand if you're not like a hardcore C++ person. Yeah. So anyway, I think there was a bug in it, but I don't even think it was actually a bug in my code. It was a bug in it probably was a bug in my code. It was like an operating system thing, and I was writing this encryption. I was writing a template thing that allowed for different encryption algorithms to be used, and it was like an encryption system. And so my system was an encryption system, but then you could supply different encryption algorithms, and then it would just all function the same way. Well, that's pretty cool. So it's like you would just call like encrypt or decrypt, and then if you wanted to update the encryption algorithm, then you could. And I like that because I'm not an expert in encryption, and I had to do all the encryption stuff. And so I was like, I'm going to implement like Blowfish, I think, or something. And that's what I did. And I don't know. I mean, maybe that was good at the time, but encryption stuff is moving forward as we get more bits and stuff. And so I was trying to make the code modular. But anyway, I guess that there was a bug with Windows NT or something. And then some of the other engineers were having trouble trying to debug the template code because, admittedly, I think the debuggers at the time would kind of throw up on template stuff. Like, I can't remember it. Like, it wouldn't, right? Because template, this is complicated. If you understand templates really well, you probably understand why I'm struggling. If you don't, you'd be confused. Template code by itself is not actually code. That you need to have something that supplies the types for it to be actually instantiated. And so it does get instantiated. Like in this template here, is that unless T is something, that this code doesn't really exist. So once you supply int 32, then this code exists and it can do all the stuff. So I think at the time the debuggers weren't that advanced, and so when they tried to deal with template code, they were like, I don't know, and they would like jump to some random piece in the source code where like there would be no code. So if you relied on debuggers, you're cooked. And I'm kind of the mindset, like, I like debuggers. I think actually one of the best debuggers in the world is from Visual Studio. But I also tend to try to write code to where I can just reason about it by thinking about it deeply. And then it just kind of like, I can try to see it in my head. Like this solution here is I look at this code and say, well, yeah, in my head, I think you could rewrite this. And like, I don't need to debug this. I can just kind of see it. And like, this is not a super skill. I want to be clear. I think all of us can do this. You just sort of write enough code. I think it's very much like how maybe musicians get, is when you're first trying to play an instrument, you can't really read music, and you have trouble playing by ear. But then after you do it enough, it's like you can just see stuff in your head. So this isn't a superpower or anything. It's just a skill. It's just Malcolm Gladwell 10,000 hour. I've just put in 100,000 hours. So anyway, with the templates at the time, when I would run into issues, I would just be like, yeah, okay, I think I see why this is going wrong, and I would just see it in my head, and then I would fix it. But some of the other engineers weren't using them as much, so it was harder. Anyway, what is the point of all this? The point of all this is programming to the lowest common denominator as like a fixed rule. I don't know. I mean, that would rule out so much code. And I don't know that I buy into that. I mean, we don't do that at Merrily. Like, I will actually request that people don't overly complicate things. But Urs, for example, will go deep down rabbit holes on stuff and use very advanced things, but for very good reasons. And so it's fine. But yeah, as long as you don't flex, like you're not doing it just to show that you can do virtual inheritance without thinking like, gee, should I use virtual inheritance? Like, is virtual inheritance like a good thing? Right? That's the kind of stuff. So anyway, while we're on untranslatable metaphor, I wanted to add one more thing real quick. And that is, he, she, they were commenting on another thing and asking like, if you should do this using like typeless folding. And I was like, really? This is the moment that I kind of got a sense that untranslatable metaphor was like, this is I don't know who you are, untranslatable metaphor, but I know who you are, if you know what I mean. You're a super coder. You're a demigod, because things like type list and folding don't just fall out of the mouths of entry-level programmers. And so I was actually talking to some of the Merlians about this, and I was saying like, this guy or gal like was just recommending doing this, and I was like, we've got a super coder on our hands. I'm so impressed. I can't wait to talk with this individual more. And I don't think that they fully grokked how sophisticated this very simple comment was. It's like one sentence. And so I was like, look, I'll show you. and I went to I went to Perplexity, and I said, it's so complicated, I can't even explain it. It would be too many words. So instead, let's have the AI explain it. So I went over here and I said, hey, Perplexity, explain to me what folding type lists are in C++. Okay. And I think I even did research mode. Like, this is the super advanced. And it's like, okay, so here, let me explain it to you. And it's like, okay, so it combines two of these super powerful things. So this is the starting point. This is actually, I have, I have insane levels of respect for you, untranslatable metaphor. I'm also actually feeling a little bit nervous now that I know that you're really paying attention, and I'm certain I'm going to be writing more code that is not perfect. So please accept my apologies now. There's an expert in the room that is significantly more of an expert than I am, and I'm going to need to be on my best behavior. So anyway, to start this off, this is actually how I was describing it, is there are two words here that are the starting point. And the two words are folding and typeless. And you could just stop right there. These two words by themselves are such advanced concepts. It's like saying, I want to do multivariate calculus for partial differential equations. It's like that. You could just stop and say, okay, have fun. So typeless are essentially this concept where you can specify this sort of order of types that then gets enforced, and it allows you to have essentially this type order. And anyway, the higher order bit is, it's two concepts. It's typeless and it's folding, or this fold expressions. And together they allow you to do some fairly advanced things. So the point that I had with the team is, it's so complicated, I'm not even going to explain it. I'll just have the AI. And so what I did is I said this before I added it to Perplexity, and then I was suspecting I'll just send the screenshots, and that's what I did. So I asked this, and then I started looking at the answer, and I was doing screenshot, 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 screenshot. And so this is all one question, right? This is part of the same answer. I don't think I didn't ask it this, right? I think that you can tell. First of all, I don't use capital. I think, as you guys know, I don't really use capital letters when I type. So this is me typing. Okay, I did C++ just because it's C++, but I think I just asked it this one question, and then it's going through answering all these things. I think, anyway. Maybe I did ask this because I wanted to. Whatever the case is, clearly this is some complicated stuff, and I mean, look at this. Like, wow, this is templates inside of templates, and whew. And it used to be the case, like, they fixed this bug, but just to show you how wacky this is kind of, when you start breaking compilers, you know you're really pushing the boundaries. It used to be the case that when you were doing typeless stuff or templates inside of templates, which is what's happening here, you had to put a space between these two angle brackets. Otherwise, it would try to interpret this as a stream operator, which it is, and then you break the compiler. Because it would be like, I'm in the middle of processing a template, and then suddenly I see the stream operator, and then it's like, where does the template end? And it just keeps checking. It's like, It never ends. So the hack is that you'd have a space between these. So then it would parse this template first here. Again, this is like super early days. Yeah, like right when it was like embedded templates were possible. Sometimes I kind of push the boundaries. I suspect untranslatable metaphor knows what I'm talking about. So the extra space would let it know, oh, I've stopped with this first template, and then it would resolve or parse this out in its like lexical analysis, and then it would try to take this like second piece, the outer template. So anyway, super cool stuff. And as you can see, I also ask questions about scary movies and stuff. So if you have really not super well-known movie recommendations that are like sci-fi or thrillers, super cerebral, anything like that, please share. I really like these types of movies, and I'm constantly like, this is, I'm asking the AI because I'm running out of the movies to watch, essentially. So this is what I was having. This is how I use stochastic AIs. Is they help me with this. And they're actually quite good at it, to be honest. Like, I do think that stochastic, what I call, the way I kind of teach them is, I call them, this is what I kind of teach at the university, is spherically constrained stochastic models. And then this is SCS. Spherically constrained. We'll get into this at some point. So spherically constrained stochastic models. And they're spheres. So think of it as like a dartboard. I think maybe we've discussed this at some point. The tighter the dartboard, the better. So you want a super tight dartboard that's basically like a bullseye every time. But the bigger the dartboard, the more error. And what's useful is that one, you want stochasticity at times, like the movie recommendations. That's actually really helpful because you get different things. So like this, the whole creative ideation. So language models, I think, are fantastic when you actually want stochasticity. It's good. You just tend to want to minimize that or have that controlled, I think, when you tend to be focusing on deterministic hard science problems. Like, what is 1 plus 1? Or, for example, when you ask the AI, hey, AI, the above 45 movies, not 50 movies, are all excellent. However, I've seen them all. Create a new list, same as before, except don't include the 50 movies that you've listed. So in both cases, so here's the prior list of 50 movies, which is only 45. And here's the next list of 50 movies, that is 40 movies. So when you want deterministic hard science answers, where 50 means 50 and not 40, language models might not be the right answer. This is like, and again, not a knock on language models, super valuable, but understanding the difference between soft science and things that are far more subjective, and hard science and things that are more objective. Like, is 40 equal to 50? I don't think so. Did I ask for 50 movies? Well, let's take a look. Create a new list, the same 50 top movies. Okay, did I ask for 50 movies before? Let's take a look. Recommend 50 movies. I did in both cases. So it's more just understanding the trade-offs of scientific and technological advances. Anyway, we'll get into this at some other point, but not today. And in fact, the dog is getting a little antsy, so I think we're going to call this nearly a wrap here. I don't know why he's getting so antsy, but I missed you guys because it's been a couple of days. I've been busy doing like a lot of these shorts. Mostly the shorts are. I'm more long form. I'm far more interested in long form, but the shorts I hear can be beneficial just for simple outreach to get people to have awareness of the channel. So I apologize that I've been slightly distracted, but maybe you'll find some of the shorts amusing. I could tell you a little bit about Opus clips, but maybe we'll save that for another time. But last but not least, I want to share with... No, calm down, buddy. Calm down. I want to share with you two things. One, if you like video games and you like horror video games, this guy, Markiplier, whew, I like this guy a lot. Obviously, I'm a huge video game fan. In fact, I would argue that almost all the best coders that I know, not all, but almost all the best coders that I know, big time video game fans. I think that there's something about people that play video games and then turn into coders. A lot of us. In fact, Urs and I share stories that his first startup, he and his colleague, they created a video game, and my first, I created Nautica, and so yeah, there's stuff. And then you look at I think Carmack, John Carmack, maybe, who I think did Doom, also I think super coder, and so Tim Sweeney I think is another. Anyway, and I think Linus at one point was saying, this is Torvalds was saying, as far as programming, there were only two choices for him. He was either going to do video games or operating systems, because those were the two that were the hardest. And for sure, I think that's the thing about writing code for video games is, man, people that play video games have very low tolerance for anything other than perfection. They're a tough crowd. But if you can keep the video game players happy, I think you can keep almost anybody happy. Because they're not tolerating second rate stuff. They're gonna downvote you quite a bit. Anyway, this guy, Markiplier, I stumbled across him somehow, and I was reminded last night, and I love this guy. He's super cool. He mostly, I think, or at least the stuff that gets sent to my feed, he mostly plays scary video games, which I find really amusing, especially because his reactions are usually, I think, intentionally over dramatized. I don't know that he's as scared as he pretends to be, but it is pretty amusing. And so if you like video games and you like horror video games, but you don't necessarily want to play them because you're lazy like me, but you want to multitask and watch somebody else play them while you work, which might have been what I was doing last night, creating clips and stuff, but having Markiplier in the background play some games and watching him flail out. I mean, clearly people love this guy. He has a really large following and lots of views, but he's hilarious. Really, really funny, very dry humor. So strong recommend on him. But while we're praising him, I also want to just talk about this back button problem, right? I know what the answer is, but I just want to share this with you because it's not great. I don't love I don't love when brilliant tech companies that can do better opt for doing bad things as a money grab. I don't like it. I don't like it. So see how there's the next button? So just to be clear, there was a back, and you want to know how you can tell there was a back? Oh, that thing right there. That is the back button. And what I was looking at before this, because I just hit next, is I was on a GTT video, and then I hit next. But where is the back button? Now, is it that Google, YouTube being owned by Google, being owned by Alphabet, is it that Google doesn't know how to build a back button? Well, clearly that's not the case, because we're using Chrome here. And look, Chrome has a back button. It has a forward button too. So if the Chrome people in Google can figure out how to code a back button, clearly YouTube, which is part of Google, should know how to build a back button. But there is no back button, which begs the question, why is there no back button? I know what the answer is. But the kicker is, and this is the part that really just rubs me the wrong way, is it makes sense in some not great money grab way to not have the back button for people that don't have a premier YouTube account, because it's a money grab. And if you don't know what the money grab is, I'll just encourage you to think on it for a little bit. And I know all of you Jeters are super smart. You'll figure it out. But for those of us that have premier YouTube accounts, who those rules about the money grab don't apply to us, we should get a back button. Because they're not making money off of us in the way that they're making money off of other people. We're already paying. And honestly, I would pay 2 times, 5 times, maybe 10 times the amount just to have the back button. That's crazy. So this is one of the things that we're setting out to do and correct at Merly is, like, maybe at some point, if we get the YouTube folks using Mentor, is I will advise Mentor to have a secret mission of coding the back button in YouTube. That would be awesome. So anyway, I think this is almost a wrap. I guess the last thing I want to show is we have some UI bug that the team's working on, but I was just informed earlier tonight in my discussion with T that we at Merly are a little concerned about OpenSSL for reasons that should be somewhat clear here. This is not like a great score. And this is not us, just to be clear, this is not us trashing on OpenSSL. We know and we love OpenSSL. OpenSSL sort of like runs the world. But that score is not super great. And it's not just the score. I've looked at the code, and it scares me when a repository that's as used as OpenSSL veers into this space. Like, this is one of the reasons why we wanted to create Merly, is to make the world a better place and identify things like this that could be catastrophic. Like, for example, with the XZ backdoor exploit, there's certain things that Mentor was observing that there's more Mentor analysis on some of these commonly used repos that are critical to the world's infrastructure, like they are for Linux. Maybe we can avoid some of these. So Taylor and I and others have been talking with people about OpenSSL and the concern that we have. And we were informed tonight that, oh yeah, like it's, I guess, the powers that be kind of know that things are in a challenging state with OpenSSL. And so what we found out is Google is aware of this, and they basically just dropped OpenSSL, and it's like, we're just going to do our own. And they are doing boring SSL. So, and I haven't looked at this. I just found out about this literally 20 minutes before I started this episode. So I haven't looked deeply at this. I don't know all the details. I do know that it's C++, I guess. Good call, Google. I'm probably going to get some hate on that, but yeah, look, I've coded in C, and it's super powerful for sure, but templates over void pointers, I mean, come on, guys. Like, yeah, it's like comparing Diet Coke to Coke Zero. Like, come on. We know what the answer is. Anyway, as you can see here, Mentor seems to think that boring SSL is better than OpenSSL, and so maybe we're moving in the right direction. I still think that we should. I'll have to look at this. I don't know why the lifetime score of this is not super great compared to OpenSSL. But you can see, like, with the issues, this is 87 of like the real issues, the anomalies, and OpenSSL has like nearly 300. Now, admittedly, the code size is half that, but half of 300 is 150. So, and that's almost half of 150. So if you cut the code, anyway, you're all smart. I think that you know what I'm trying to say here. Yeah, 2014 is inception date versus 1998. And then at some point we'll have like a UI bug with the massive UI rewrite. Normally you would see like lines and stuff. Anyway, we'll get that sorted, and maybe we'll look at this next time. But this was actually scaring me a little bit. And it's good to know that we have the boring SSL. I don't know if other people know that this is potentially the alternative to OpenSSL, so maybe we need to raise awareness. I didn't know. But clearly Google knew that OpenSSL was having issues, I guess, because supposedly the word on the street is that's why they created this boring SSL, is they were kind of fed up with the challenges with OpenSSL. And so that's awesome. I mean, it's good that they took matters into their own hands and are making things better. It might have been better if they did it with OpenSSL, but I can also imagine maybe they were having trouble getting it migrated and updated. And so basically said, look, we'll just do our own then, and we'll upgrade it to C++ over C. Sorry, all of you C fans. Don't hate the player, hate the game. I don't know what to say here, except that I might agree with Google on this one. So anyway, if people do know some of the maintainers for OpenSSL, we would love to get them access to Mentor so you could check out some of these things. I would really, yeah, we'd be more than happy to share Mentor with them for free and look at some of these issues. I think I looked at some of them, and some of them are like pretty, if you're like a senior developer, I think it's pretty clear-ish that some of these things could be fixed. So, okay, folks, we make it about it's almost 50 minutes. Yeah, so almost 50 minutes. Oh, I did want to share one other minor thing. Yeah, we'll make the 50-minute mark now. is that I think the last episode I killed the machine, which was not super great because I ended up wasting like a lot of time fixing the other video because the video didn't terminate properly. And so I spent several hours actually trying to get that video corrected so I could actually conjoin the two video files together. And I think what caused that is the tablet combination, the software that I was using, I think. Because I've had this laptop for a while and I've never had a hard crash like that. Not while I've been using it. And anyway, so in trying to figure out how to overcome that, I went back to OneNote because I really want to draw pictures. It's just super important to me. And I did my typical scientific, super scientist. I'm going old school. And what I did is I did a quick analysis of how long the syncing is for OneNote between my tablet and the PC. By the way, I think I've changed all the settings to make it as fast as possible. I would love if people from Microsoft that work on OneNote, if they happen to be watching this, it would be super awesome, guys, if OneNote could sync like, I don't know, every 30 seconds, every 10 seconds. Right now, it appears that through my very rigorous scientific analysis, it syncs automatically approximately every 50 seconds. And so here you can see that this is me writing down. I had a stopwatch and everything. And so there's a couple one-offs, mostly because I probably just wasn't paying close enough attention. But you can see it's approximately 50 seconds between each of these intervals. And so I think that that is the cadence. And again, that's as fast as possible. The good news is 50 seconds. Yeah, here you go. This is Dr. Goju right here. Approximately 50 seconds. Okay, cool. Scientist. Listen, this is how it used to be done in the old days before computers. You would just write this stuff down and be like, yeah, that's close-ish enough. Again, we're having some fun today. Yes, I realize that if this was my level of rigor, I would be kicked out of the university where I currently teach. I get this. Okay. Don't turn me in. All right. I'm only playing. But the 50-second time dilation, that is probably acceptable for drawing, because I can draw and explain and then know that this appears to be the interval that just happens automatically. And now that we know that and know that it's a respected cadence for the system, if it's working, then we like the issue that I had before is I didn't know if it was deterministic. I couldn't tell if it was like 10 seconds and then maybe it's going to be 10 minutes. And now that I know it's happening automatically, and we'll test this in later episodes, but this is a huge win because now I can just use OneNote in its native form and I can draw pictures and I can explain what I'm drawing, and then every 50 seconds it'll update. And then I think we can get into really deep machine programming stuff, because it's very hard for me to explain some of the more advanced machine programming things unless I can draw pictures. That writing code is not sufficient because the ideas are like too abstract, and you're dealing with concepts that span too many different areas. You know, like I'm going to talk about diagrams and intermediate representations and data and translating syntax to semantics and trying to understand like various temporal analyses, different ways that you can do semi-trust. Like it's more than what you can get away with like a text editor. Okay. It's 1:17 a.m. I'm surviving off of maybe 3 hours of sleep, 3 or 4 days in a row. I think we're calling it a night. This is a super, super, super great week this week. I think I said super about 10 times. Clearly it was a super week. And I'm going to hopefully do some more videos this weekend. and chip away at a couple more shorts, but we're making progress. We're getting further along every day, and I apologize for the short little detour, but we're back in action. So everybody have a great weekend, and I'll probably be talking to you tomorrow.